Welcome back to our build, everybody. We are most of the way through the install of the thermal buck and the high performance windows, and I'd just like to show you, we came up against an issue that I'm sure we're not the only ones who have had, but we're probably the only ones who have made a video about it and for sure have mentioned it to the manufacturer of the window or the inventor and manufacturer of thermal buck. So let me just show you what's going on. Here is a door that has not been thermal bucked yet. It is just a simple 2x6 framed wall with a 1/2 inch sheathing on it. So 2x6 is 5.5 inches, plus the 1/2 inch of sheathing is a 6-inch deep space. Now, the way that American doors are made is that you have a frame and then there's a brick mold attached to it. This door is made so that you slide it, you can only install it from outside. You slide it in, and this flange right here, which is called the brick mold, hits against the outside of the house. This is generally not a problem for typical construction where you're not using exterior insulation. You just put the frame into the door here. The brick mold sits right up against the sheathing that you've got. And then you can screw the frame through the, like behind the weather stripping. Generally, you're gonna peel back the weather stripping and drive the screws in there, or through the hinges on the hinge side. And you're able to hit the structure. Now, check this out. When you use exterior insulation, you're gonna need some way to give yourself a surface to trim to, because when you're gonna bring your cladding alongside, if you imagine you put 2 inches of exterior insulation on here, how am I gonna attach my cladding, the siding or whatever it is that I'm using to look at on the surface of the building? How am I gonna attach it to the structure if I don't have a way to do that here? So that's what a buck does. This happens to be made of high density styrofoam insulation, as you already know. And this is 2.5 inches deep. That's because we're using 2 inches of insulation plus a 1/2 inch ventilation rain screen. So now I've got my door frame and I'm gonna install it, but it's gonna wanna sit out here, which means that now the screws that the manufacturer has very carefully pinpointed to go into the structure are not gonna go into the structure where they think they're going to. So now I have to move back my screws potentially out into the visible space that's not hidden behind weather stripping. This becomes particularly important in a case like this. This is an 8-foot tall, double wide, mostly glass French door. So, the mistake that I've made is that number one, we have both 2x6 walls and 2x4 walls in this house. You'll see why in either the design videos at the beginning of this playlist or later on when we get to the installation, but we're only insulating with 3.5 inches of insulation everywhere. That gives me a channel inside, and so that's kind of a cool thing. You'll see that. That's how we're not embedding plumbing and electrical stuff inside of my insulation, which is a good thing, and behind my air sealing layer. But I made a mistake. Somehow it got past me that this door was ordered with a 4-inch jamb. And so if we install this the way that the manufacturer intends, by putting the, first of all, lifting the entire thing assembled up into place, which we are not doing, that's ridiculous. It weighs 800 pounds, and you can see that I'm standing on the ground right now and the door is way up there. So if we put the thing in there and then assemble it, we'll end up with almost no space to screw through the jamb of the door, the frame, into actual structure in our house. This was potentially a no-go situation. We are in conversations with the window manufacturer and thermal buck manufacturer, and they're saying, you know what, we haven't thought about an outswing door that weighs so much just hanging on the thermal buck, because the thermal buck is clearly not intended for you to hang the entire weight of your house. It is supposed to carry quite a bit of weight per square foot. I think it's 800 pounds per square foot, roughly. But still, long term, thinking about these doors opening and closing and putting more and more stress and twisting this thing, I'm not gonna do that. I feel nervous enough. I'm not a structural engineer, but I know that can't be right. And so we were at a stalemate and there was no way to do this. But that night, when we were in the middle of this, I got off the phone and my builder friend, Michael Dunseith from the Green Jobs Training Center, happened to be stopping in, and he happened to overhear my conversation. And he said, you know, you shouldn't think about this whole door assembly as one thing. It's really a bunch of component parts. To get these doors to be truly outswing, meaning they would come all the way out and then keep going all the way back to here, we would need the hinges to be all the way out here, which gives me until here, which is just past my sheathing. Basically what we would have to do is screw in 3/4 of an inch from the edge of the jamb, and in that case we would only be 3/4 of an inch into the framing on the inside. That's basically just clipping both of them. I would consider that being tacked in place, no matter how permanently you do it. So first option is, well, what if we just trim this little jamb extension off, which we did, and move it back a little bit. Now the doors cannot truly open all the way out like this. They can only open to 90 degrees. And we still have the issue of how much weight is there going to be bearing on this, because we're still well inside the thermal buck here. We're not in the framing when we go through the hinge security holes. Basically, these holes are where you're going to go 1 screw each all the way into the framing. And in order to really hit that, we need to move this thing back a considerable distance. So instead of thinking this as one piece, we took the brick mold off. The brick mold used to be right here. Once you take the brick mold off, now this door could be an outswing door, or it could be an in-swing door. It doesn't matter. And we're gonna flip this around, make it an in-swing door instead, and that way we can get the hinges to line up with the frame. Let's go ahead and do that real quick. The thermal buck serves 2 purposes, one of which is to put all of our holes in the enclosure, the doors and windows, inside of insulation. But we're not gonna use that feature. What we are still using this for, and it's still good for, is trimming so that we have a place to attach all of our exterior cladding. And I am still getting the benefit of the, if you want to be nerdy about it, the thermal bridging of places around the doors and windows. I still have a 1/2 inch of high density polystyrene insulation here, so that the heat does have to work a little bit to bleed around this thing. And that is better than plywood or hardwood at that point. This is the way that we fix this problem. I hope that this has been helpful to you if you ever come up against this. There are probably other ways to do this. If you've had this issue and you've solved it a different way, please do comment below. Remember to like and subscribe. Tune in next time.